Hey, check, check, check. So for this lesson, we will solve the app to configure the subnet VLSM, just assign the IP address in each network, and we will configure a static routing to each network in that section. I will download the app. You can search in the drive.
Welcome to Germany's IT lab.
And we will see the app info in here, so we can download packet subnetting VLSM lab. Can solve this lab. We will try to solve this first. Can open. So for this network, we have 5 subnets in here. So the IP address will be 192.168.5.0/24. For the step here, we got the first step. We have to subnet the 192.168.5.0/24 to a 5 subnet for each LAN. Also the point-to-point connection between R1 and R2. And the second step will be assign the first usable address to the PC in each LAN. Assign the last usable address to the router's interface in each LAN. And configure static routes on each router so that all PCs can ping each other. The first usable address to the PC in each LAN, and the last usable address to the router interface in each LAN. First step, we have to configure the subnetting for 5 subnets in here. And for the VLSM methods, we have to see the most large host in this network. So it will be LAN 2. So I will have to type in here for LAN 2 that get 64 hosts. For the 64 hosts, we have to make it /20 /26 will be 62 usable address. So we have to make it /25. 192.168 .5.0/25. That will get 128 hosts. The first work will be this one. broadcast will be 7. And first usable address will be 192.168.5.1, and last usable address will be 126. For the second largest host or subnet in here, we got LAN 1. Have to copy this LAN 2 for the LAN 1. 45 hosts. 5 hosts. And for the 45 hosts, we will get slash 26 for the 64 hosts. Yes, 26. For the hosts, for the network, we will get 128. 128. And plus 4 will be 192. So the one 28. Okay. 191 for the broadcast, and the first usable address will be 120. 29. And first usable address and last usable address. Yes. 64 hosts. The 6. And then for the third largest subnet or host will be for the LAN. And we will get 32 in 6. S27 will be 30 hosts, and slash 28 will be 16 14 hosts. So it covers for the 14 hosts. So we will choose slash 28. So we'll use slash 28 for this. coding. And for the next IP address for this broadcast will be 192, and 192 plus 16 will be 208, and 208, 207, 207 is broadcast address for this LAN 3. And the first usable address will be 1, and last usable address will be 6. The last, the fourth largest will be for the LAN 4. It has 9 hosts. So for the 9 hosts, we will use slash 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 28, 14 slash 29 will be 6 hosts. So we will use slash 28 again. Slash 28 for this next IP for the broadcast will be 208, 208 plus 16, 224, 224. The broadcast will be 223. And the first usable address will be 209. The last usable address will be 222. That's 28. And for the last section, we will use slash 30 for this point-to-point connection for the two routers in here. We will name it P2P in here. It require 2 hosts. So we will use slash 28 16 slash 29 8 slash 30 will be 4 hosts, is 2 hosts plus 30. So we will use slash 30 in. And for the network, the next IP for the broadcast address in LAN 4 will be 224. So for the network and P2P will be 224. And for the broadcast address, 224 plus 4 will be 226. And 225 will be the broadcast address in P2P here. And the first usable address will be 225. And the last usable address will be 226. I mean, for the broadcast address will be 224 plus 4 will be 228. First usable address 225 and last usable address will be 26. Okay, so we already do the subnetting in this network. It contains 5 subnets, and the first subnet will have to be the largest host in the subnet, and it will be for the LAN 1. for the for host. For the second steps in here, we have to assign the first usable address to the PC in each LAN. So we will assign for LAN 2 and 2, get to the config, and for assign the last usable address to the router's interface in LAN. Routers each the last usable address in each. So um, we have to set the default route for the connection to the PC to the router in the PC's default route, so it will be connected to the router's fast Ethernet 1 here. The LAN 2, we will type in 192.5 dot subnet mask 255.255.0. For the settings will be default gateway will be 192.5 dot 6. We leave it the DNS server because we will not use the DNS server. Slash real static route. For the second largest host in this network will be the LAN 1. We can configure the IP address settings. The default gateway will be the last IP address 168. Dot 5.19 5 5.19 IP for the fast Ethernet 2.18.5. 29. The subnet mask will be for the slash 26. We will get for the subnet subnet mask for the slash 25 will be at 128. For the slash 26 will be plus 64 plus 19. We change that subnet 120. For the LAN 3, I'm gonna type the subnet 458.255 dot 192. plus 32 4 plus 24 plus 16 plus 8 plus 4. The 4, and we use slash 28 again, so it will be for the slash 28 25 26 28 25 26 28 26 27 192 for the slash 6 7 to 4 plus 16 will be 240 with 224, and same for this LAN 4 that has 9 hosts. So for the subnet we'll get the slash dot 24 in here, and for the P2P we will get for the slash 20 28 29 30 252. For the next we will assign the default gateway, the PC's IP for the third largest host or subnet in this network. So it will be LAN 3. We click on the PC3 interface, settings, and the default gateway we will see here for the last usable address for the LAN 3, 192.168.5.206, and for the fast in this PC we will get 168 dot 5.193 subnet 40. For the fourth largest subnet host, we will configure LAN for the 9 hosts. Click the physical interface, go to the settings. Default gateway will be the last usable address as we do before. 6.5.222. The fast it will be 92.168.5.209. The sub mask will be 40 because it plus 16. We will use 16 hosts, 14 hosts for this 9 hosts in 209. For this section, we will use peer-to-peer hosts. So we have to configure this interface IP address, enable conf interface D0 2.16. 192.168. Hmm. Two to five and 255.255.252 is good. The surface G plus 2.155 to 6 255.252 to R1. It, it, so we already configure and assign those IP address for the first usable address to each PC in each LAN, and we already assigned the last usable address to the router's interface in each LAN. So we have to assign those IP address for the default route in each section. We will switch the interface E00 will be dot 68 5.9 5 1 and 2. G0 space G0 let's see for G00. The next subnet we will use, we will configure the default gateway. This one space G01 LAN 2 in 0.126 works 2.168 6 over 5. all the stuff get done. Masuk dulu entry s 300 s 1 8 254 bit 5 bit 4 down 3 8.5.222 right outer right it this interface we will test the connection between the host for each subnet to its default route. I think the router thing T01 in 1 bit. Okay, we'll try the thing. The other one. Okay. It's 8.5. Probably it became same, but for it has good can will do the 68 5 plus destination host on plan for can be ping as we ping for the LAN 3. So in here instructions configure static routes on each router so that all these can ping each other. So for the I have to configure a route to LAN 3 and LAN 4 so it can be communicated or connected for each other so they can ping. Have to configure the IP route for the two endpoints in IP route. The address route address. Use your IP route. So be connected route dot 1.8.3 5.192 to 55 5 route question ABC prefix destination prefix forward to 55 forwarding routers. For this next hop, address will be 00 router to this. This will be 192.1.5.226 for the LAN 4 network 208 for the net mask is same as LAN 3 so 8.240 and for the next hop will be 5.226 between R2's 000 4 we do show you can see here we're connected with the static symbol here. We connected LAN 3 and LAN 4 via R2's G00 interface. This will be the IP for G00 and R2. And we have to configure the each out for the LAN 1 and LAN 2 in R2's interface. Enable const IP route network for LAN 1 22.168 5.1 for subnet 5.2 2 /26. For the next, we are once the 00 interface, it will be 225. It will 5.5. So we have to route the LAN 2 also. Will be LAN 2 5.0. And 192.1 5.2 to 5. Okay. As you can see, static routes already figured. So you can send the ping command. Will ping the first visible address or the PC3 IP address 5.1. This time the 3 repeating requests will ping for the run 1 PC1 to PC3 successful, and we will test for the PC ping 8. Five dot 209. Gonna using the app because of the ARP request will be showing up the request timeout because it called the ARP. Okay, for the PC through 3. Okay. 1 2 8 and 4 5 2 3. Let's go. This test. This.
Along with the series. Also, please like and leave a comment. Share the video to help spread this free series of videos. Thanks for your help. Also, remember to download this practice lab, link in the description. Try it out yourself in Academy. In this lab, we will practice subnetting using VLSM, variable length subnet mask. It will be very similar to the end of day 15's lecture video. We will subnet a Class C network into 5 subnets of different sizes. So I highly recommend that you try to complete the lab first, before watching this video to check your answers. We are required to subnet the 192.168.5.0/24 network to provide sufficient addressing for each length, as well as the point-to-point connection between R1 and R2. We will follow the same process that I introduced in day 15's lecture. Assign the largest subnet at the start of the address space, and then the second largest, etc., until you have assigned each subnet. That means we will assign subnets in this order: 2, and 1, and 3, 4, and finally the point-to-point link. The instructions also say to assign the first usable address to the PC in each LAN, and the last usable address to the router. Finally, we should configure static routes so that hosts in each LAN can reach hosts in the other LAN. So let's get started with LAN 2. I hope you've already solved this lab and are just watching this video to check, since I won't go step by step through each calculation. Let me tab out to this document, calculated all of the answers. So for LAN 2, we must use a /25 prefix length. LAN 2 only requires 64 hosts, and as I've written below, a /25 prefix length allows for 126. But if we use the /26 prefix length, there would only be enough addresses for 62 hosts, because we have to subtract 2 for the network and broadcast. So LAN 2's network address is 192.168.5.0, and its broadcast address is 192.168.5.127, both /20. Let's assign the addresses to PC2 and R1. Let me go on R1 first. First, enter privileged exec mode with enable, then enter global config mode with configure terminal. R1's Gigabit Ethernet 01 interface is in LAN 2, so interface G01 configure. Broadcast address is 192.168.5.127, so let's configure R1's IP address as one below it, the last usable address. IP address 192.168.5.126, and for /25 prefix length, subnet mask will be 255.255.255.128. Also, let's enable the interface with no shutdown. From our configuration, do show IP interface G01. Show IP interface command shows various information about the interface, primarily layer 3 information. You can see here that the IP address has been configured correctly. You may notice the broadcast address of 255.255.255.255. This address basically functions the same as the subnet broadcast address of 192.168.5.127, and it can be used for any network. When we configure other IP addresses and use this show IP interface, those other interfaces will display the same broadcast address. Keep in mind, if a host sends a broadcast to 255.255.255.255, it won't be sent to all networks. It will still stay in the local subnet. The router will not route it to other networks. Subnet broadcast 192.168.5.127 in this case can be used by hosts in other subnets to send a broadcast to this subnet. Anyway, I think I'll explain that in a lecture video in the future, so don't worry about it. I just wanted to explain it since you can see it here. Okay, now let's configure PC2. Click on config, then first set the default gateway to R1, 192.168.5.126. Then click on fast Ethernet 0, and set the IP address and subnet. First usable address is 1. After you enter it, you can press fill in the subnet mask for. However, since this isn't a classical order, it's a subnet. Let me change the last octet to 128. Okay, that's all for this subnet. Second largest subnet is LAN 1. Let me go back to my document and let's look at it. So for LAN 1, we use a /26 subnet. LAN 1 requires 45 hosts. A /26 subnet mask allows 62. Network address is the next address after LAN 2's broadcast address, so it's 192.168.5.128.26. Broadcast address, all host bits at 1, is 192.168.5.128. Let's configure the router and the PC. I'll go back to R1. Let's configure the G00 interface with the last usable interface G00. IP address 192.168.5.190, 255.255.255, which is the subnet mask. 6 figures. Enable the interface with no shutdown. Do show IP interface G00. IP address is correct, and you can see the same broadcast address. 255.255.255.255. Let's configure PC1. Set the gateway to 192.168.5.190. Then click on fastKey 0. The IP address to 192.168.5.190. Tab. And then change the last octet to 192./36 prefix. That's all for LAN 1. Next up is LAN 3. Let's go back to that document. So for LAN 3, we will use a /28 prefix LAN, which allows for 14 hosts. Exactly the number we need for LAN. Line a real network. Leave some extra room for future. So when taking a test, do exactly as you. Network address is the next address after LAN 1's broadcast address. So it's 192.168.5.192/28. Broadcast address is 192.168.5.207. Figure part 2. Enable G interface G00. Let's configure the last usable address. IP address 192.168.5.206. 255.255.255.240, which is the subnet mask for /28. Enable the interface with no shutdown. And let's convert to show IP interface G00. The IP address is next. Let's configure PC3. The gateway address to 3.168.5.6. Click on fast Ethernet 0. IP address of 192.168.5.193. Hit tab, and change the last octet here to 240. Okay, that's all for LAN 3. Is LAN 4. Go back to that document. So for LAN 4, we will actually use /28 also. And /29 prefix link. The network address is 192.168.5.8. Address is 192.168.5.2. Here it's G01 interface. It's G01. 192.168.5.222. 255.255.240. Enable the interface with no shutdown. Do show IP interface G01. Okay, the IP address looks correct. Go to PC4. Big is the gateway to R2's address. 2.168.5.222. If it's 0, set the IP address to the first usable address, 192.168.5.209. Hit tab, change the last octet of the subnet mask to 240. That's all for LAN 4. The last subnet we have to establish is the point-to-point connection between R1 and R2. Let's go back to the document. So we can use /30 or /31. I'm going to go with /30. I just think it's the safe option to go with. Our address is 192.168.5.224. And broadcast address is 192.168.5.227. First usable address for R1. Usable address for R2. In fact, those are the only two usable addresses on R1. Is G000. IP address 192.168.5.225. 5.255.252. Enable the interface. No check it. Let's check it. Do show IP interface G000. Okay, the address looks good. Let's go on R2. Interface G000. IP address 192.168.5.226, 255.255.255.252. And enable it with no shutdown. Finally, let's confirm. Do show IP interface G000. Okay, no problems here. Now, the last step is to configure static route on. The driver has 3 connected networks. Those are the point-to-point lane, and LAN 1 and LAN 2 from R1, LAN 3 and LAN 4 from R2. So, configure 2 static routes for each route. First, let's configure the routes to LAN 1 and LAN 2 here on R2. Exit to go back to global config. First, LAN 1. IP route. Then LAN 1 network address. 192.168.5.128, 255.255.255.192. Let me use the question. Note that you can either specify the exit interface or the IP address of the network. I'll go with the next font. 192.168.5.225. Okay, that's it. Next to LAN 2. IP route 192.168.5.0. 255.255.255.128, then the next hop of 292.168.5.225. Let's check the route table. Do show IP route. Okay, you can see the connected and local routes here. Two static routes we just configured. Let's go on R1 and configure the routes to LAN 3 and LAN 2. First, exit to return to global config. So the route to LAN 3. IP route 192.168.5.192, 255.255.255.240, and the next hop of 192.168.5.226. Okay, now to IP route 192.168.5.208, 255.255.255.240, 192.168.5.226. You show IP routes. Okay, okay. One has all the routes it shows. Let's just try to ping from PC1. Upgrade verify exit. Same for 20, H5, and VLAN 30. Here are the topics we will cover in today's video. First, what is LAN? It stands for Local Area Network. I'll give you a more specific definition. VLAN, virtual LAN. I will teach you the basics of the standard. Finally, we will look at the basics of VLAN configuration on this course. By the way, the only video. The next video, day 17, will also be a VLAN. So this video will start the Let's start. So, what is a LAN? In the previous video, I said that a LAN is a group of devices, PCs, in a single location. Let's take a look at a more specific thing. LAN is a single broadcast domain. Broadcast domain is the group of devices which will receive a broadcast frame with the destination of all X by any one of them. Take a look at it. So take a look at this network here. How many broadcast domains do you think there are? Remember, a broadcast domain includes all devices that will receive a broadcast frame. So let's say PC1 sends a broadcast frame. And remember that a broadcast frame is a frame with a destination MAC address, all X. Which devices will receive the frame? Well, this PC1 sends the frame out towards switch 1. And what does the switch do with the broadcast frame? It floods it with all interfaces, except the one it was receiving. So the frame is sent to PC2 and R1. What does the router do with the broadcast? It doesn't forward it. It will receive the frame, but it won't send it to other networks. So that means this is one broadcast domain, including PC1, PC2, switch 1, and one of R1's interfaces. So that's one broadcast domain. How many are left? What if PC3 sends a broadcast? Which devices will receive it? Which two will receive the frame and flood it out of all interfaces through R1, PC4, and PC5. R1, however, will not forward the broadcast. So that's the broadcast domain. PC3, PC4, PC5, switch 2, and one of R1's interfaces. So far, we have found two broadcast domains. Now, how about if PC6 sends a broadcast frame? Which devices will receive it? When switch 3 receives it, it will flood the frame to PC7, PC8, and R2. R2 will not forward the frame. So this is the broadcast domain, including PC6, 7, 8, switch 3, and one of R2's interfaces. So we found three broadcast domains. However, there is one more. What if R1 sends a broadcast frame out of its interface, which is connected to R2? It will be received only by R2. However, even though this is a connection between only two devices, it is still technically a broadcast domain. So, do you understand what a broadcast domain is now? Broadcast domain is the group of devices which will receive a broadcast frame with a destination MAC address of all Fs sent by any one of the members. In this network here, there are 4 broadcast domains, therefore 4 LANs. Here is a small LAN of a company. Let's say there are 3 main departments in this office: engineering, sales, and human resources. Also, the company is using the 192.168.1.0/24 network for this LAN. However, this isn't necessarily the best setup. For both security and performance purposes, it will be best to split up these into separate subnets. For example, let's say it will be best setup. For both security and performance purposes, it will be best to split up these into separate subnets. For example, let's say a PC in the engineering department sends a broadcast message intended for other PCs in the engineering department. Since it's a broadcast message, the switch will flood it out of all interfaces. So, not only will the PCs in the engineering department receive the broadcast, all PCs, as well as the router, will receive the broadcast. This is a problem for both security and network performance purposes. When it comes to performance, lots of unnecessary broadcast traffic can reduce network performance. Whether it's a broadcast from one end host,
the VLANs topology. Yes, of the existing called broadcasting. There isn't a VLAN that going on in one network. When you separate other department engineering as examples, this network topology, the, the PCs will sense the broadcast message when it sends the packet. Example, it will float the device and the lots of it will be the problem for the performance problem because lots of unnecessary broadcast traffic can reduce net performance. So that's why I VLAN. And VLAN indicated in that it will be separating the network. When you um, send the network traffic or the broadcast message, will do the unicast the destination. It will not flood all the ports and it will be good for the performance back.
Or a switch that doesn't know how to reach the destination MAC address, so it floods the frame. We should minimize unnecessary traffic in our network. As for security, even within the same office, we want to limit You can apply security policies on a router or firewall. Because this is one LAN, PCs can reach each other directly without traffic passing through the router. So even if you configure security policies on the router, they won't have any effect. We should separate these hosts so we can apply security policies that determine who can access what in the network. So let's split up these departments into separate subnets. 192.168.1.0/26 for the engineering department, 192.168.1.64/26 for the HR department, and 192.168.1.128/26 for the sales department. However, there's one problem. The router is going to need an IP address in each subnet, so it will need one interface in each subnet. So let's replace this single connection between the switch and router with 3 separate connections, one in each subnet. Actually, there is a more efficient way of doing this. You don't actually have to use 3 separate interfaces. But don't worry about that for now. I will cover that in a future video. So you may think the problem is solved now. Let's say this PC in the engineering department has an IP address of 192.168.1.1, and this PC in the sales department has an IP address of 192.168.1.129. If PC1 sends some data to PC2, PC1 will recognize that PC2 is in a different subnet than its own. So it will set the destination MAC address to its default gateway, R1. This is what the frame will look like. Source IP of PC1, destination IP of PC2, source MAC of PC1, and destination MAC of R1. PC1 will forward the frame to the switch, which will send it to R1, which will then change the source MAC to its own MAC and the destination MAC to PC2's MAC. It will then forward the frame back to the switch, which will then forward it to the destination, PC2. Okay, so instead of PC1 being able to send traffic directly to PC2, we forced it to send the traffic through R1 first, where we would have configured some security policies and such to control exactly what traffic is allowed to pass between these subnets. However, there is still a problem. Here's the problem. What if the frame is a broadcast or unknown unicast frame? The switch will flood the frame out of all interfaces. For example, here's a broadcast frame. The source IP is PC1's IP, and the destination IP is its subnet's broadcast address. So this is a broadcast frame intended to the engineering department. The source MAC is PC1's. The destination is the broadcast MAC address of all X. Where is the problem? Well, remember that a switch is only aware up to layer 2. It looks at layer 2 information like source and destination MAC addresses only. It doesn't care about layer 3, 4, etc. So, even though there are 3 separate subnets here, the switch doesn't know that. PC1 will send the frame to the switch. It will see the destination MAC address of all X, and then flood the frame. I'll say it again. This is bad in terms of both network performance and security. So I've shown you that although we separated the 3 departments into 3 subnets, meaning they are separated at layer 3s, they are still in the same broadcast domain, the same layer 2 network, or the same LAN. A possible solution is to buy a separate switch for each department. However, that is not very flexible, and network equipment isn't cheap, so buying 1 or more switches for every single department could be too expensive, especially for a small enterprise. However, this is where VLANs come in. Although these PCs are all in the same LAN, local area network, we can use VLANs, or virtual local area networks, to separate them at layer 2. We'll assign the engineering department to VLAN 10, HR department to VLAN 20, and the sales department to VLAN 30. How exactly do we assign these hosts to VLANs? We configure them on the switch. More specifically, on the switch interfaces. You configure the switch interface to be in a specific VLAN, and then the end host connected to that interface is part of that VLAN. The switch will consider each VLAN as a separate LAN and will not forward traffic between VLANs, including broadcast or unknown unicast traffic. So, if we have set up these VLANs, if PC1 sends this broadcast frame, after the frame arrives at the switch, it will be forwarded to all interfaces in the same VLAN. Because the broadcast arrived on an interface configured in VLAN 10, the switch will only forward the frame to other interfaces in VLAN 10. If PC1 wants to send the same unicast frame to PC2, it will function just like before. It sends it to the switch, which sends it to the router, which changes the source and destination MAC addresses, and sends it back to the switch, which sends it to the destination. Notice that the router is used to route between VLANs. The switch does not perform this inter-VLAN routing. It must send the traffic through the router. Notice that traffic erupts. The switch will only forward the frame to other interfaces in VLAN 10. If PC1 wants to send the same unicast frame to PC2, it will function just like before. It sends it to the switch, which sends it to the router, which changes the source and destination MAC addresses, and sends it back to the switch, which sends it to the destination. Notice that the router is used to route between VLANs. The switch does not perform this inter-VLAN routing. It must send the traffic through the router. Notice that traffic arrives on a VLAN 10 interface and is forwarded out of a VLAN 10 interface. Also, traffic that arrives on the VLAN 30 interface is forwarded out of a VLAN 30 interface, both in the same VLAN. A switch will never forward traffic directly between two VLANs like this. Well, first of all, the two hosts are in separate subnets, so PC1 itself will send the traffic to its default gateway, R1. However, even if PC1 and PC2 were in the same subnet, the switch wouldn't forward the traffic from PC1 to PC2 because they are in separate VLANs. Just a bit of review. VLANs are configured on switches on a per interface basis. VLANs logically separate end hosts at layer 2. Although the hosts in the topology we looked at were physically connected to the same switch, and therefore in the same broadcast domain, we used VLANs to logically separate them and put them in separate broadcast domains. Switches do not forward traffic directly between hosts in different VLANs. As I showed you, the switch must forward the traffic to a router. Actually, there are a couple other methods of inter-VLAN routing, and I will cover them in a future video. Finally, let's take a look at basic VLAN configuration. I've added the interface numbers to the diagram. Interfaces in VLAN 10 are G10 through G13.
Hey!
Interfaces in VLAN 20 are G20 through G22. And interfaces in VLAN 30 are G30 through G33. Let's go into the CLI and put these interfaces into the proper VLAN. Before configuration, let's look at the VLANs that exist by default on a switch. In this output, you can see I use the command show VLAN brief. It displays the VLANs that exist on the switch and which interfaces are in each VLAN. Here you can see VLAN 1, the name default. This is the VLAN that all interfaces are assigned to by default. So even if you don't configure any VLANs, all interfaces are in VLAN 1 by default. Under ports, you can see all of the interfaces on this device, from G00 to G33. Under it are 4 other VLANs, 1002 to 1005, used for FDDI and token ring. These are old technologies that you don't need to know for the CCNA, but feel free to Google them if you're curious. VLANs 1 and 1000 to 1005 exist by default and cannot be deleted. Remember that. This is how you assign interfaces to a VLAN. First, I use the interface range command to configure all of the VLAN 10 interfaces at once. Use the switch port mode access command to set the interface as an access port. What is an access port? An access port is a switch port which belongs to a single VLAN and usually connects to end hosts like PCs. That's why it's called an access port. It gives the end hosts access to the network. There is another important type of switch port called a trunk port. Switch ports which carry multiple VLANs are called trunk ports. I will cover trunk ports in depth in the next video, but for today's video, we'll focus only on access ports and take it step by step. A switch port connected to an end host should enter access mode by default. However, it's always a good idea to explicitly configure the setting, not rely on auto-negotiation of port type. Anyway, the last command after switch port mode access is switch port access VLAN 10. This is the command that actually assigns the VLAN to the port. Notice the message that appears after this command. Access VLAN does not exist. Creating VLAN 10. Because VLAN 10 didn't exist on the device yet, it was created automatically when we assigned the interface to VLAN 10. I'll show you how to manually create a VLAN in the next slide. Next, I again use the interface range command to configure all of the VLAN 20 interfaces at once. I use the same switch port mode access command, then switch port access VLAN 20 to assign the interfaces to VLAN 20. Finally, I did the same for VLAN 30, and once again, the VLAN was created automatically. So, I used the show VLAN brief command once again, and here you can see the 3 VLANs we created, and the ports we assigned to each VLAN. Notice the default names of each VLAN. Let's change those to make it more understandable. So, I used the VLAN 10 command to enter configuration mode for VLAN 10. By the way, this is the command to create a VLAN also, but in this case, it was already automatically created when we assigned the interfaces. Next, I assign the name with this simple command, name engineering. Then I do the same for VLAN 20, HR, and VLAN 30, sales. Finally, I confirmed once more with show VLAN brief. Notice that the names have been changed to engineering, HR, and sales. Okay, so that's all for the configurations. If I use the command ping 255.255.255.255 on PC1, which sends a ping with the destination MAC address of all S, the broadcast MAC address, the broadcast will only reach hosts in VLAN 10. Likewise, if I use the same command on PC2, the broadcast will only reach PCs in VLAN 30. Okay, so before moving on to today's quiz, let's review what we covered. We talked about what a LAN is, and I defined it as a broadcast domain, the group of devices that will receive a broadcast sent by another member in the group. Then I talked about what a VLAN is. It's essentially a way to logically split up a layer 2 broadcast domain, make multiple separate broadcast domains. We also talked about the purpose of VLAN.
What is a LAN? LAN is the group of devices that is in the network broadcast domains. So for the example is for the network home or the school in the same area or the small area is called the LAN or local area network. For the broadcast domain, the definition of broadcast domain will be broadcast domain is the type of network that will be in one single area, like for the devices PCs connected to switch. So when the PCs will be getting a ping, which one will be float all the interface except or will be received on mm, it will be flowed to all device, and that is VLAN technique or the protocol in the network that we use to segment or or separating the the network that will be preventing broadcast storm.
We talked about what a LAN is, and I defined it as a broadcast domain, the group of devices that will receive a broadcast frame sent by another member in the group. Then I talked about what a VLAN is. It's essentially a way to logically split up a layer 2 broadcast domain, make multiple separate broadcasts. We also talked about the purpose of the.
So for the LAN is the one broadcast domain or the group of one device that will be connected one to each other. What is VLAN? VLAN is the way to segment the network into many broadcast domains.
It's essentially a way to logically split up a layer 2 broadcast domain, make multiple separate broadcast domains. We also talked about the purpose of VLAN. The two big reasons are network performance and security. VLANs help to reduce unnecessary broadcast traffic, which helps prevent network congestion and therefore improves network performance. Limiting broadcast and unknown unicast traffic like this also improves network security, since these messages won't be received by devices outside of the VLAN. You should always make sure that network traffic isn't sent unnecessarily to other devices, as much as possible. Finally, we looked at how to configure VLANs on Cisco switches. Specifically, we configured access ports on a Cisco switch and assigned them to a specific VLAN. There is still plenty to cover about VLANs, but this should be a good foundation. In Day 17's video, we will cover more topics regarding VLANs. Okay, let's go on to today's quiz. First up, question 1. How many broadcast domains are shown in this network diagram? Pause the video and count how many broadcast domains you see. Note that no VLANs have been configured, so all hosts are in the same default VLAN, VLAN1. Pause the video now. Okay, let's check the answer. There are 6 broadcast domains in this network diagram. Basically, each router interface and everything connected to it are in one broadcast domain, since no VLANs have been configured. Let's go to question 2. How many broadcast domains are shown in this network diagram? Take note of the configured VLAN. Pause the video to think about your answer. Okay, let's check. There are 5 broadcast domains here, one for each of the configured VLANs, and the connection between the 2 routers is a broadcast domain. As well. Let's go to question 3. What happens if you try to assign a switch interface to a VLAN that doesn't exist? A. The command will fail. B. The switch will create the VLAN. C. The interface will be disabled until you create the VLAN. D. All VLANs exist by default. Pause the video to think about your answer.
The switch will create VLAN.
Okay, the answer is B. The switch will create the VLAN. As I showed earlier in this video, if you assign a switch interface to a VLAN that doesn't exist yet, the switch will create the VLAN automatically. Let's go to question 4. If PC3 sends a broadcast message, how many devices will receive it? Pause the video to think about your answer. Okay, let's check the answer. The answer is 3. First of all, the switch will receive it. Then it will send it out of all interfaces in VLAN 20, so the router and the other PC in VLAN 20, making a total of 3 devices. If no VLANs were configured, all other PCs would receive it. But since we have configured VLANs, only these devices in the same VLAN will receive it. Let's go to the final question, question 5. You create VLANs 10, 20, and 30 on a Cisco switch. How many VLANs will be displayed in the output of the show VLAN brief command? A, 3, B, 5, C, 8, or D, 10?
How many VLANs will be displayed in the output?
Pause the video to think about your answer. The answer is C, 8. Let's check it out. As you can see, there are 8 total VLANs. VLANs 1 and 1002, 3, 4, and 5 exist by default and cannot be deleted. So if you create 3 additional VLANs, there will be a total of 8 VLANs on the switch. Okay, that's all for the quiz. There will be supplementary materials for this video to help you review and practice what you've learned. There will be a flashcard link in the video description.
Yeah, I just want attention. You're on my heart. Baby, you just stop for us. I don't know. Which ports which carry multiple VLANs are called carry multiple VLANs? Port. What VLAN are Cisco switch interfaces by default? VLAN 1, VLAN 1002, and 2005. Figure the VLAN switch port. VLAN which port mode S which port mode dan the number of which port access VLANs are used to split up broadcast. VLANs operate at layer 2 of the PC. Rare VLAN number. Configure the name of VLAN and name of VLAN. Command good device will receive a frame with the destination MAC address of all F's broadcast. Configure switch interface to be an access port. Which port mode access which port access VLAN number. port will a layer to switch forward traffic between VLANs or VLAN route. What are the 5 VLANs that exist by default on a Cisco switch? VLANs 1002 to 1005 and 1. Port is a switch port which belongs to a single VLAN and usually connects to an host like PCs on switch. What VLAN are Cisco switch interfaces by default? 1. VLAN operate at 2 of the C node. VLANs are used to split up broadcast domain where the VLAN switch ports which carry multiple VLANs are called trunk ports. Configure a switch interface to be an access port. Port mode access. Configure the VLAN of a switch access port. Configure the VLAN of switch access port. Which port access, which port access VLAN number. Configure the name of VLAN and VLAN net name. What are the 5 VLANs that exist by default on a Cisco switch? VLAN 1, VLAN 1002, VLAN 1003, VLAN 1004, VLAN 1005. Broadcast domain. Will a layer do to switch forward traffic between VLANs or VLAN routing? No. And access port. On things I never wanted, the same old bar.
Welcome to Jeremy's IT Lab.
Show you the shape of my heart. I will shine it, be so. Play my part, kept you in the dark. Now let me show. So for the VLAN part 1 video for Jeremy's IT lab, we will configure the day 16 lab for the VLANs part 1. Okay, for the step here, for step 1, we have to configure the correct IP address or subnet mask on each PC. Set the gateway address as the last usable address of the subnet. Make 3 connection between R1 and switch 1. Configure one interface on R1. Configure one interface R1 for each VLAN. Okay. Make sure the IP address are the gateway address you configure on the PC. Make sure the IP address are the gateway address you configure the PC. Default gateway. Configure switch 1 interface in the proper VLANs. Remember the interface that connect to R1. Name the VLANs, generating HR cells. Ping between the PCs to check connectivity. Send the broadcast ping from PC or ping the subnet broadcast address. And see which PCs devices receive the broadcast. Use packet tracer simulation mode. figures which ones interface the proper VLANs, right? The step one, figure the correct IP address or subnet mask on each PC. Set the gateway address as the last physical address of the subnet. So the gateway address will be our default route on the R1. Config for the VLAN 10. Okay. And the mask
So for you, other written O.O flash we can get the console trains the address as it will be O.O. And the O click on that will be the default gateway of the subnet. And set then adjust the subnet map 26 so 5.255 hit tab and then adjust the subnet mask to 255.255.255.192.
/20. So for the /20 mask the 255.255.192. Default gateway, we have bilang itu 0. Will be 5. That's okay. Address. for this 5. What gateway plus 60. Things 0 0 0 30 30. Copper straight cable 00 G01 01 to G4 G02 to configure one interface on R1 for each VLAN. First of all, I will configure the default route G00. Address will be the last usable address on a VLAN 10. So for the IP address, it will be 10 0. For what gateway will be 60. It to hash will be 2555 19 slash 20. To enable the queue. No, sir. To check the interface P01 to the last usable address on VLAN, it will be 120.0.0.26 description to VLAN 20. Oh, shut down. interface. G02 IP address and 0.0 will be the default route. So password 255 then then configuration we have to assign VLAN one interface on R1 for each VLAN and make sure the IP address or the gateway address you configured on the PC. Configure switch one interface in the proper VLANs. For the interface that so we have to add to create a VLAN here for each interface. See? And name interface as net 3124 x 4 yeah, S range 13 but F 4 okay, will be switch port mode switch port S active. The ports is still not active for VLAN 10. So we have to configure capacitor ports with the VLAN 10. The command is access
First, I
bus range switch port access it and the range range the tiga per satu sampai Press range F3 per 1 Yeah. And as for dinner and guys, lima sport says for film 10 and 20 already in the correct ports. For the 10 film 10 engineering, it's the access port and the F31, and for the film 20 HR will be through on access port within the fast Ethernet 5.1 and fast 6.1. And we name else this which which will show the sales is the correct ports also. Now we have to configure the trunk ports for the G001 through G01 and the VLAN engine sales ping between the connectivity broadcast ping PC to configure the trunk ports. Yes, it's to the router. SB01 which port
Baru gue nyalain.
more Prog switch port VLAN
because it's a /26 subnet. Oh. Okay, that's all for PC1. I'll quickly run through the other PCs now. PC2 is next. Go to the Config tab, gateway address of 10.0.0.62, go to the network interface, IP address of 10.0.0.2, and subnet mask of 255.255.255.192. Okay, that's all for the VLAN 10 PCs. Next is VLAN 20. So I'll go on PC3. Config, set the gateway address of 10.0.0.126, the last usable address of the subnet. Then configure the network interface. Address of 10.0.0.65, subnet mask 255.255.255.192. Okay, now let's go to PC4. Config, gateway address of 10.0.0.126, then .SIP2. Okay, those are the PCs in VLAN 20. Finally, let's configure. Okay, those are the PCs in VLAN 20, 255.192. Configure PC5 and PC6 are the VLAN in the config last usable address of the subnet. And okay, final and down for switch one next is switch one G G's subaddress and 10 255.255.down. Okay, next up G01. It is show command. There are the 3 gateway addresses we configured for each VLAN. Let's see. VLAN 10.1. Now we are configuring all 3 interfaces at once. Let's configure the interfaces as access ports with this command. Switch port mode access. It should enter that mode by default, but it's best to manually configure it. Remember, an access port belongs to a single VLAN, as opposed to trunk ports, which we will cover in day 17's lecture video. Next, let's assign the VLAN. Switch port access VLAN 10. Okay, that's it. Let's go on to VLAN 20. Interface range G11, F51, F61. Switch port mode access. Switch port access VLAN 20. Okay, finally, let's do VLAN.
So our configuration were wrong to time that G01, G0, G11, G21 respond to wrong ports. I have to configure it to port set interface G01 and G0 G0 access.
Accept stupid names now. VLAN 20 main tip activity. I'll do some pings from PC1. I'll ping to in VLAN 30. Ping 10.0.0.129. And ping PC3 again.
That's from the PC1, PC5, and think that will be pin 5.
Okay, let's do that again. In 10.0.0.65. Okay, so PC1 sends the ping to switch 1, then it goes to R1, then back to switch 1, then to PC3. Okay, so PC1 sends the ping to switch 1, then it goes to R1, then back to switch 1, then to PC3. And the return follows the same path. So R1 is doing the inter-VLAN routing for us because it has one interface in each VLAN. Okay, let's do one more test. I'll ping VLAN 10's broadcast IP, which is 10.0.0.63, and let's see if the broadcast only goes to devices in VLAN 10 as a chip. Let's try. In 10.0.0.63. Okay, there we go. It is sent to switch 1, which then forwards it only to R1 and PC2. Okay, in this lab we did basic configuration of access ports on a Cisco switch. That's all for this lab. Allowed on the trunk. For a quick review, here is the network topology used in the last video. There is a single switch and 3 VLANs. All of the switch interfaces are access ports, which belong to a single VLAN, either VLAN 10, VLAN 20, or VLAN 30. 3 interfaces are used to connect to the router, one for each VLAN. For this video, let's use a different network topology. Here's the network topology we'll start with for this lesson. This time, there are 2 switches used. Note that VLAN 10, the VLAN for the engineering department, is split between the 2 switches. This is very common, as departments in a company aren't always split up exactly by location. You might have some engineers on one floor of the building, for example, and some on another floor. We are still using only access. There are 2 links between switch 1 and switch 2, one for VLAN 10 and one for VLAN 30. There must be a link in VLAN 10 between the 2 switches because VLAN 10 PCs are connected to both switch 1 and switch 2. And also because the PCs connected to switch 1 need to be able to reach R1 via switch 2. As for the link in VLAN 30, it is necessary because PCs in VLAN 30 also need to be able to reach R1 via switch 2. There is no link in VLAN 20 between switch 1 and switch 2. This is because there are no PCs in VLAN 20 connected to switch 1. PCs in VLAN 20 can still reach PCs connected to switch 1. R1 will perform the inter-VLAN routing. Let me demonstrate that inter-VLAN routing. Let's say this PC in VLAN 20 wants to send traffic to one of the VLAN 10 PCs connected to switch 1. It will send a frame with a destination MAC address of R1, its default gateway. R1 then forwards it back to switch 2. Note that this traffic arrived at switch 2 on the VLAN 10 interface. The traffic is now in VLAN 10, so it forwards it to switch 1 on the VLAN 10 connection between them. Then switch 1 forwards the traffic to the destination PC. So you can see that even though there isn't a VLAN 20 connection between switch 2 and switch 1, the PC in VLAN 20 can still send traffic to the PC in VLAN 10 because the router performs inter-VLAN routing. In a small network with few VLANs, it is possible to use a separate interface for each VLAN when connecting switches to switches and switches to routers. However, when with few VLANs, it is possible to use a separate interface for each VLAN when connecting switches to switches and switches to routers. However, when the number of VLANs increases, this is not viable. It will result in wasted interfaces. Often, routers won't have enough interfaces for each VLAN. You can use trunk ports to carry traffic from multiple VLANs over a single interface.
Anjir.
These are different than access ports, which belong to a single VLAN owner.
Akhirnya menang, Vin.
Look at how trunk ports work.
Ganti menang lawan ADHD aja. Dana.
So, now I've replaced the separate connections for each VLAN
Kemenangan
with a single
perdana.
connection between switch 1 and switch 2, and switch 2 and R1. However, to make it more clear, let's add those colors back. Okay, so now you can see which VLANs are allowed on each trunk. Remember, these are single physical connections, but traffic from multiple VLANs is allowed over each trunk. Let's say this PC in VLAN 10 wants to send some data to this other PC in VLAN 10. It sends the traffic to switch 2, which then sends it to switch 1. Now, here's a question. How does switch 1 know which VLAN the traffic belongs to? Both VLANs 10 and 30 are allowed on the interface the traffic was received on. How does switch 1 know which VLAN it belongs to? The answer is VLAN tagging. Switches will tag all frames that they send over a trunk. This allows the receiving switch to know which VLAN the frame belongs to. In fact, another name for a trunk port is a tagged port, and another name for an access port is an untagged. Frames sent over access ports aren't tagged. They don't need to be tagged because the interface belongs to a single VLAN. If a frame arrives on a switch port in VLAN the switch knows the frame is in VLAN 10. Let's talk about those VLAN tags. There are two main trunking protocols, ISL, interswitch. For a quick review, here is the network topology used in the last video. There is a single switch and 3 VLANs. All of the switch interfaces are access ports, which belong to a single VLAN, either VLAN 10, VLAN 20, or VLAN 30. Interfaces are used to connect to the router, one for each VLAN. For this video, let's use a different network. Here's the network topology we'll start with for this lesson. This time, there are 2 switches used. Note that VLAN 10, the VLAN for the engineering department, is split between the 2 switches. This is very common, as departments in the company aren't always split up exactly by location. The engineering department is split between the 2 switches. This is very common, as departments in the company aren't always split up exactly by location. You might have some engineers on one floor of the building, for example, and some on another floor. You're still using only access. There are 2 links between switch 1 and switch 2. Switches. Note that VLAN 10, the VLAN for the engineering department, is split between the 2 switches. This is very common, as departments in the company aren't always split up exactly by location. You might have some engineers on one floor of the building, for example, and some on another floor. You're still using only access. There are 2 links between switch 1 and switch 2, one for VLAN 10 and one for VLAN 30. There must be a link in VLAN 10 between the 2 switches because VLAN 10 PCs are connected to both switch 1 and switch 2. and also because the PCs connected to switch 1 need to be able to reach R1 via switch 2. As for the link in VLSM 30, it is necessary to perform the. There is no link in VLAN 20 between switch 1 and switch 2. This is because there are no PCs in VLAN 20 connected to switch 1. PCs in VLAN 20 can still reach PCs connected to switch 1. This is because PCs in VLAN 30 also need to be able to reach R1 via switch 2. There is no link in VLAN 20 between switch 1 and switch 2. This is because there are no PCs in VLAN 20 connected to switch 1.
There is no link in VLAN 20 between switch 1 and switch 2. This is because there are no PCs in VLAN 20. This is because there are PCs in VLAN connected to switch 1. This is in VLAN 20 can still reach PCs connected to switch 1. R1 will perform in VLAN route. There is no link in VLAN 20 between switch 1 and switch 2. This is because there are no PCs from 20 to switch 1. This is in VLAN 20 can still reach PCs connected to switch 1. R1 will perform inter-VLAN routing.
PCs in VLAN 20 can still reach PCs connected to switch 1. R1 will perform the inter-VLAN routing. Let me demonstrate that inter-VLAN routing. Let's say this PC in VLAN 20 wants to send traffic to one of the VLAN 10 PCs connected to switch 1. It will send a frame with the destination MAC address of R1, its default gateway. R1 then forwards it back to switch 2. Note that this traffic arrived at switch 2 on the VLAN 10 interface. The traffic is now in VLAN 10, so it forwards it to switch 1 on the VLAN 10 connection between them. Then switch 1 forwards the traffic to the destination PC. So you can see that even though there isn't a VLAN 20 connection between switch 2 and switch 1, the PC in VLAN 20 can still send traffic to the PC in VLAN 10 because the router performs inter-VLAN routing. In a small network with few VLANs, it is possible to use a separate interface for each VLAN when connecting switches to switches and switches to routers. However, when the number of VLANs increases, this is not viable. It will result in wasted interfaces. Often, routers won't have enough interfaces for each VLAN. We can use trunk ports to carry traffic from multiple VLANs over a single interface. Once again, these are different than access ports, which belong to a single VLAN only. Let's take a quick look at how trunk ports work. So, now I've replaced those separate connections for each VLAN with a single connection between switch 1 and switch 2, and switch 2 and R1. However, to make it more clear, let's add those colors back. Okay. So, now I've replaced those separate connections for each VLAN with a single connection between switch 1 and switch 2, and switch 2 and R1. However, to make it more clear, let's add those colors back. Okay, so now you can see which VLANs are allowed on each trunk. Remember, these are single physical connections, but traffic from multiple VLANs is allowed over each trunk. Let's say this PC in VLAN 10 wants to send some data to this other PC in VLAN 10. It sends the traffic to switch 2, it then sends it to switch 1. Now, here's the question. How does switch 1 know which VLAN the traffic belongs to? Both VLANs 10 and 30 are allowed on the interface the traffic was received on. But how does switch 1 know which VLAN it belongs to? The answer is VLAN tagging. Switches will tag all frames that they send over a trunk link. This allows the receiving switch to know which VLAN the frame belongs to. In fact, another name for a trunk port is a tagged port, and another name for an access port is an untagged port. Frames sent over access ports aren't tagged. They don't need to be tagged because the interface belongs to a single VLAN. If a frame arrives on a switch port in VLAN 10, The switch knows the frame is in VLAN 10. Let's talk about those VLAN 10. There are two main trunking protocols, ISL, inter-switch link, and IEEE 802.1q. Usually we call 802.1q .1q. ISL is an old Cisco proprietary protocol, created before the industry standard IEEE 802.1q. .1q is an industry standard protocol created by the IEEE, Institute of Electrical and Electronics Engineers. Remember the IEEE? How about IEEE 802.3? That's Ethernet, another industry standard protocol. You will probably never use ISL in the real world. Even modern IEEE 802.3, Ethernet, another industry standard protocol. You will probably never use ISL in the real world. Even modern Cisco equipment doesn't support it. For the CCNA, you only need to learn .1q. You should know what ISL is, but you don't have to study it like .1q. Okay, here's an old slide, back from day 5 on Ethernet switching. Do you remember the fields of the Ethernet header and trailer? If you don't, I recommend going back to check out day 5's video. I won't waste time explaining it all again here. However, the reason I am showing this is because the .1q tag is actually inserted between two fields of the Ethernet header. So here's just the Ethernet header. .1q inserts a 4-byte, or 32-bit field between two fields of this Ethernet header. Let's take a look. As you can see here, the .1q tag is inserted between the source MAC address and the type or length field of the Ethernet header. Let's go over some basics. As I just said, the 802.1q tag is inserted between the source and type/length fields of the Ethernet frame. The tag is 4 bytes, or 32 bits in length. The tag consists of two main fields. Those are the Tag Protocol Identifier, TPID, and the Tag Control Information, TCI. The TCI itself consists of 3 subfields. Let's quickly take a look at each field of the .1q tag. Here's a diagram of the .1q tag format, thanks to Wikipedia. Notice that it can be divided into 2 halves, the TPID and TCI I mentioned before. Also, the TCI can be divided into 3 subfields, the PCP, DEI, and VIB. Okay, first up, let's look at the TPID field. The field is 16 bits, or 2 bytes in length, taking up half of the 802.1q tag length. The TPID is always set to a value of 0x8100. Remember, 0x just means hexadecimal, so the actual value in the field is just 8100, 4 hexadecimal digits. Each hexadecimal digit is 4 bits, so 4 times 4 is 16, the total length of the field. This value of 8100 indicates that the frame is .1q tag. As I just showed you, the .1q tag comes after the source MAC field of the Ethernet frame. This is where the type field is usually located. When the switch sees this value of 8100 here, it knows it's a .1q tagged frame. Okay, that's all for the TPID field. Next up, let's look at the first field of the TCI, which is the PCP, or Priority Code Point. The field is 3 bits in length. It is used for Class of Service, COS, which prioritizes important traffic in congested networks. Don't worry about this field too much, just know the name and that it is used for COS. Next up is the DEI, Drop Eligible Indicator. This field is just a single bit in length. It is used to indicate frames that can be dropped if the network is congested, which makes sure more important network traffic gets through. Once again, you don't really need to worry about this field too much for your CCNA. Just know the name and its basic purpose. Okay, finally is a very important field, the VIT, or VLAN ID. It is 12 bits in length. It is a field that actually identifies the VLAN the frame belongs to. So you could say this is the most important field of the .1Q tag. Because this field is 12 bits in length, that means there are 4,096 total VLANs, because 2 to the power of 12 equals 4,096. However, the first and last VLANs, 0 and 4,095, are reserved and can't be used. Therefore, the actual range of VLANs that can be used is 1 to 4,094. By the way, Cisco's proprietary ISL, which is an alternative protocol for VLAN tagging over prime connections, also uses a VLAN range of 1 to 4,094. As I mentioned before, however, you don't really need to know ISL. It's almost being completely replaced by the industry standard .1Q. So, those are the fields of the .1Q tag. Take a look at this diagram. Do you remember the names of each section and their basic functions? If you want to read a little bit about .1Q, I recommend checking out the Wikipedia page for a solid overview of it. Okay, let me talk about the VLAN ranges a little bit more. The range of VLANs, which as I mentioned is 1 to 4,094, is divided into two sections. Normal VLANs, which are numbered from 1 to 1,005, and extended VLANs, which are numbered from 1,006 to 4,094. Some older devices cannot use the extended VLAN. However, it's safe to expect that modern switches will support the extended VLAN range. I work with Cisco switches a lot in my job, and I've never encountered a switch that doesn't support the entire range, 1 to 4,094. Just be aware that some older switches might not support the extended range. Okay, so let's look at this diagram once again. So this PC in VLAN 10 wants to send traffic to this other PC in VLAN 10. The traffic goes to switch 2, which then forwards it to switch 1, with a tag indicating that the traffic belongs to VLAN 10. Switch 1 receives the frame, and because the destination is also in VLAN 10, it will forward the traffic to the destination. Remember, a standard layer 2 switch like this will only forward traffic in the same VLAN. It will not forward traffic between VLANs. Let me introduce another concept of .1Q. .1Q has a feature called the native VLAN. Cisco's ISL does not have this feature, by the way. The native VLAN is VLAN 1 by default on all trunk ports. However, this can be manually configured on each trunk. It's important to remember that this has to be configured on each trunk port separately. It's not a global configuration on the switch. Now, what exactly does the native VLAN do? The switch does not add an 802.1Q tag to frames in the native VLAN. It will forward the frame normally, without adding the .1Q tag to it. So, what does the receiving switch do when it receives this untagged frame on the trunk port? When a switch receives an untagged frame on a trunk port, it assumes the frame belongs to the native VLAN. So, it's very important that the native VLAN matches between switches. Switches will still forward traffic if there is a native VLAN mismatch, but problems may occur. Let's look at an example. This time, let's say I've configured the native VLAN to be VLAN 10 on the trunk link between switch 1 and switch 2. Let's follow some traffic on the same path as usual. This PC sends the traffic to switch 2. It will send the traffic to switch 1, but because it is in the native VLAN, VLAN 10, it won't tag it as being in VLAN 10. The untagged frame arrives at switch 1, which assumes that the traffic belongs to VLAN 10, so it forwards it to the destination. This time, let's look at if there is a native VLAN mismatch configuration. On switch 2's interface, I've configured VLAN 10 as the native VLAN. However, on switch 1's interface, I've configured VLAN 30 as the native VLAN. Let's see what happens. Up to the point the traffic reaches switch 1, it's the same. However, when switch 1 receives the frame, this is what it will think. This frame has no VLAN tag. Therefore, it must belong to VLAN 30. But the destination is in VLAN 10, not VLAN 30. So I won't forward the frame. So I think you can see why it is important that the native VLAN configuration matches between switches. Okay, let's finally get into the configuration of trunk. I've added the interface number to the diagram to make it easier to understand. So we will be configuring G00 on switch 1 and G00 and G01 on switch 2 as trunk ports. Let's go on switch 1 first. We'll be configuring G00 on switch 1 and G00 and G01 on switch 2 as trunk ports. Let's go on switch 1 first. First, let's look at the most basic trunk configuration. Manually configuring the interface as a trunk. After entering interface configuration mode, use this command, switch port mode trunk, to manually configure the interface as a trunk. However, in this case, we got an error message. Command rejected. An interface whose trunk encapsulation is auto cannot be configured to trunk mode. This is a little tricky. Many modern switches do not support Cisco's ISL at all. They only support .1Q. Even though ISL is a proprietary Cisco protocol, even Cisco switches are moving towards supporting only .1Q. However, switches that do support both .1Q and ISL, like the one I'm using for this example, have a trunk encapsulation of auto by default. Manually configure the interface as a trunk port. You must first set the encapsulation to 802.1Q or ISL. On switches that only support .1Q, this is not necessary. After you set the encapsulation type, you can then configure the interface as a trunk. So let's see how to set the encapsulation type. You use the switch port trunk encapsulation command. I use the question mark to see the options. There are .1Q, ISL, and negotiate. Negotiate sets it to auto mode, so we can't choose that. I will talk more about auto mode in the next lecture video, by the way. So if you have questions, I will answer them there. I set the encapsulation to .1Q, and then this time the switch port mode trunk command is accepted. On switches that only support .1Q, you will only need the switch port mode trunk command. But on some switches, you will need to set the encapsulation first. I use the show interfaces trunk command to confirm. First up, the trunk interfaces are listed interfaces encapsulation first. I use the show command to set the encapsulation first. I use the show interfaces trunk command to confirm. First up, the trunk interfaces are listed here. Mode on means that the interface was manually configured as a trunk. In the next lecture, we will look at how a port can automatically become a trunk without configuration, but we'll forget about that for the moment. Encapsulation is .1Q as we configured. Status is trunking, and the native VLAN, which I mentioned before, is the default of 1. Under that, the VLANs allowed on the trunk are displayed. By default, all VLANs, 1 to 4094, are allowed on the trunk. However, for security purposes, you might want to limit which VLANs can be forwarded on the trunk. So we'll look at that configuration next. Next up is VLANs allowed and active in management domain. This includes the default VLAN of 1, as well as VLANs 10 and 30, which I already configured on this switch. Note that although VLAN 1, which exists by default, appears here, VLANs 1002 to 1005, which I showed you in the previous lecture video, do not. As I mentioned before, don't worry about those VLANs. They're not really used in modern networks. The last field of the show interfaces trunk command is VLANs in spanning tree forwarding state and not pruned. I'll talk about this in a future lecture. We don't know about spanning tree and VLAN pruning. Here is the command to configure the VLANs allowed on the trunk. Switch port trunk allowed VLAN, and then there are some options. Word allows you to simply configure the list of VLANs allowed. Let's see how that works. So I use the command switch port trunk allowed VLAN 10, true. Notice that the show interfaces trunk command now only shows VLANs 10 and 30 as being allowed on the trunk. Now let's take a look at the add options. This allows you to add allowed VLANs to the currently existing list. Currently, VLANs 10 and 30 are allowed. Let's say I also want to add 20. even though no host in VLAN 20 are connected to switch 1. This time I use the command switch port trunk allowed VLAN add 20. The show interfaces trunk command now shows VLANs 10, 20, and 30 as allowed, so 20 was added to the list. Note that because I haven't actually created VLAN 20 on the switch, VLAN 20 still isn't displayed in the VLANs allowed and active in management domain section. Next up, I'll show you the remove option. VLAN 20 isn't necessary on this, so let's remove it. I use the command switch port trunk allowed VLAN remove 20. Now, as you can see, VLAN 20 has been removed from the list of allowed VLANs, leaving only VLANs 10 and 30. Next up, let's look at the all option. I think this one is fairly obvious, but let's take a look anyways. This time I use the command switch port trunk allowed VLAN all. Now all VLANs are allowed on the trunk. This is the same as the default state, as all VLANs are allowed by default. Next up, let's look at the accept option. It allows all VLANs except the ones you specify. Let's check it out. I use the command switch port trunk allowed VLAN except 1 to 5, 10. As you can see, it allows all VLANs except those. So 6 to 9 and 11 to 4094. Okay, finally, let's look at the none option, which also is pretty easy to understand. This time I use the command switch port trunk allowed VLAN none. And as you can see, no VLANs are allowed on the trunk. This effectively allows no traffic to pass over the trunk. So now let's do the actual settings we want for this network. Here's the diagram once more. Switch 1 has hosts in VLAN 10 and VLAN 30 connected to it. No hosts in VLAN 20 are connected, so there's no need to allow VLAN 20 on the trunk between switch 1 and switch 2. Just for this network. Here's the diagram once more. Switch 1 has hosts in VLAN 10 and VLAN 30 connected to it. No hosts in VLAN 20 are connected, so there's no need to allow VLAN 20 on the trunk between switch 1 and switch 2. So let's set the allowed VLANs to 10 and 30 like we did before. Okay, there we go. Now the only VLANs allowed on the trunk are VLANs 10 and 30. The reason to do this is for security purposes, to make sure only traffic in the necessary VLANs can use that connection. Also, for network performance purposes, this avoids unnecessary traffic, because broadcasts and such in other VLANs won't be sent over the trunk. Now, I said I'd show you how to change the native VLAN. For security purposes, it is best to change the native VLAN to an unused VLAN. Network security will be explained more in depth later in the course. This video is already getting long, so I won't explain the detailed reasons. But again, it's about limiting unnecessary traffic in the network and controlling what traffic is allowed. Also, remember to make the native VLAN match between switches. Now let's look at how to change the native VLAN. The command to change the native VLAN is native VLAN, followed by the VLAN. I chose an unused VLAN, 1001. As you can see, the native VLAN has now been changed to 1001. After configuring the trunk port, edit the show VLAN brief command. Notice that G00 is not listed anywhere, not in VLAN 10 or VLAN 30, even though those are the VLANs allowed on the trunk. This is because the show VLAN brief command shows the access ports assigned to each VLAN, not the trunk ports that allow each VLAN. Use the show interfaces trunk command instead to confirm trunk ports. Now that we've seen the configurations on switch 1, I'll quickly do the configurations on switch 2 as well. On switch 2's G00 interface, we must allow VLANs 10 and 30. On switch 2's G01 interface, however, we must allow VLAN 20 as well. Here are the configurations for switch 2's G00 interface, the interface connected to switch 1. These are the same as before, so I won't go through each one. You can pause the video if you want to take a look at them individually. Now let's move on to G01, which is connected to R1. Okay, here are the configurations. Almost identical to G00, except I allowed VLAN 20 in addition to VLAN 10 and 30. Now both G00 and G01 are displayed in the output of the show interfaces front center. So that's all for the switch configuration for this lesson. However, you may be wondering about the router. In the previous lecture, we used 3 separate interfaces for the connection from switch 2 to R1, and assigned a separate IP address to each one on R1. Each one served as the default gateway address for the PCs in each VLAN. However, now we are using only one physical connection between the two devices. So we must use sub-interfaces on R1. Let's take a look. First of all, take a look at each one of the connect. That's the show interfaces front connect. So that's all for the switch configuration for this lesson. However, you may be wondering about the router. In the previous lecture, we used 3 separate interfaces for the connection from switch 2 to R1, and assigned a separate IP address to each one on R1. Each one served as the default gateway address for the PCs in each VLAN. However, now we are using only one physical connection between the two devices. So we must use sub-interfaces on R1. Let's take a look. First of all, take a look at the title of the slide. Router on a stick, also written as
Wah, benini. Bobo basing ano?
It's a bit of a strange name, but it's the name used for this method of inter-VLAN routing, as there is only a single physical interface connecting the router and the switch, and it looks like a stick on the network topology diagram. So in this case, that one physical interface being used on R1 to connect to switch 2 is G00. It's connected to G01 on switch 2. But we can actually divide this one physical interface into 3 separate sub-interfaces, which will allow us to perform inter-VLAN routing with only one physical interface. So it would look like this. G00.10 for VLAN 10, G00.20 for VLAN 20, and G00.30 for VLAN 30. These 3 logical subinterfaces are really one physical interface, G00, which is connected to switch 2 G01 interface. But they can operate like 3 separate interfaces. Before we look at the router configurations, note that we don't need to do any additional configurations on switch 2. We already configured G01 as a trunk and made sure that VLANs 10, 20, and 30 are allowed. That's all you need to do on the switch. Configure the interface like a regular trunk. Now let's look at the router configurations. Here are the configurations. First, make sure the interface is enabled with no shutdown, as router interfaces are disabled by default. Next up is the first sub-interface. Notice how to enter sub-interface configuration mode. Interface G00.10. This sub-interface number does not have to match the VLAN number. However, it is highly recommended that they do match to make it easier to understand. If each sub-interface's number matches the VLAN number, it's easy to see which sub-interface is used for each VLAN. The next command after that is encapsulation.1q, followed by the VLAN number, which is 10 in this case. This tells the router to treat any arriving frames tagged with the specific VLAN number as if they arrived on this sub-interface. If a frame arrives tagged with VLAN 10, R1 will behave as if it arrived on interface G00.10. It will also tag all frames leaving this subinterface with VLAN 10 using .1q. Finally, after the encapsulation.1q command, simply assign the IP address to the subinterface. Once again, I have assigned the last usable address of the sub, and that's all for this subinterface. Then I did the same thing with the other two sub-interfaces. Again, I made the sub-interface and VLAN numbers match, and configured the last visible IP address of each subnet as the IP address of the sub-interface. If you confirm with the show IP interface brief command, you can see that each of the sub-interfaces appears, as well as the physical interface, although the physical interface itself has no IP address assigned to it. And here is the routing table. Notice the connected and local routes are added, just like when IP addresses are added to regular physical interfaces. When R1 sends frames out of these sub-interfaces, it adds the VLAN tag configured on the sub-interface. For example, if a packet arrives destined for the 192.168.1.64/26 subnet, it will send the packet out of its G00 interface, tagged with VLAN 20. Okay, let's review the important points about router on a stick. ROAS is used to route between multiple VLANs using a single interface on the router and switch. The switch interface is configured as a regular trunk. The router interface is configured using sub-interfaces. You configure the VLAN tag and IP address on each sub-interface. The router will behave as if frames arriving with a certain VLAN tag have arrived on the sub-interface configured with that VLAN tag. Finally, the router will tag frames sent out of each sub-interface with the VLAN tag configured on the sub-interface. Now that we have configured the router, let's return to this diagram to see how inter-VLAN routing works with these sub-interfaces. This PC in VLAN 10 is trying to reach this PC in VLAN 30. The frame is sent to switch 2. Switch 2 sends the frame on its G01 interface to R1, tagging it as being in VLAN 10. R1 receives it on its G00 interface, identifying it as arriving on the G00.10 sub-interface because of the VLAN 10 tag. The destination is in the subnet 192.168.1.128/26, which is connected to R1's G00.30 sub-interface. So it sends the frame out of its G00 interface. It tags it as VLAN 30 because that is what was configured on the G00.30 subinterface. Switch 2 then forwards it to switch 1, tagging it as VLAN 30 over the front. Switch 1 then forwards the frame to the destination. Okay, let's quickly review before moving on to today's quiz. I think I say this after every video these days, but there was a lot of information in this video. Please re-watch 30 parts of the video if you need to, and use the supplementary materials to help you practice and review as well. First off, we answer the questions, what is a transport? It's a switch interface that carries traffic over multiple VLANs. We also answered what the purpose of a transport is. It allows switches to forward traffic from multiple VLANs over a single physical interface, instead of having to use a separate physical interface for every single VLAN. I also introduced 802.1q encapsulation, which is a tag inserted into the Ethernet frame and is used to identify which VLAN the frame belongs to when sent over a transport. I showed how to configure transports on a Cisco switch, including the encapsulation type, allowed VLANs, and native VLAN. Finally, I showed you how to configure router on a stick, which involves configuring multiple sub-interfaces on a single physical interface, which again allows for traffic from multiple VLANs and subnets to routers without having to use a separate physical interface for each one. It's like a trunk port on a router. Finally, let's move on to today's quiz. First up, question 1. You want to configure switch 1 to send VLAN 10 frames untagged over its gigabit Ethernet 01 interface, the front. Which command is appropriate?
We want to configure switch 1 to send VLAN 10 frames tag over its gigabit Ethernet 0. Which command is appropriate?
A. Encapsulation.1q10. B. Switch port trunk allowed VLAN 10. C. Switch port trunk allowed VLAN add 10. D. Switch port trunk native VLAN.
One time VLAN many frames for each gigabit Ethernet 01 interface RAM. Which command is appropriate? Interface gigabit 01 is RAM interface. So we have to load VLAN. The answer is B.
Pause the video to think about your answer. The answer is D. Switch port. Trunk native VLAN 10. A. Encapsulation .1q10 is used on a router subinterface to specify which VLAN it belongs to. B and C are used to modify the VLANs allowed on the trunk. D is used to specify the native VLAN, and traffic in the native VLAN is sent untagged over the trunk. Next, let's go to question.
You can configure switch 1 to 7 frames at gigabit 01 interface. Yep.
Let me introduce another concept of .1q. .1q has a feature called the native VLAN. Cisco's ISL does not have this feature, by the way. The native VLAN is VLAN 1 by default on all trunk ports. However, this can be manually configured on each trunk. It's important to remember that this has to be configured on each trunk port separately. It's not a global configuration on the switch. Now, what exactly does the native VLAN do? The switch does not add an 802.1q tag to frames in the native VLAN. It will forward the frame normally, without adding the .1q tag to it. So what does the receiving switch do when it receives this untagged frame on the trunk port? When the switch receives an untagged frame on the trunk port, it assumes the frame belongs to the native VLAN. So it's very important that the native VLAN matches between switches.
When a switch receives an untagged frame on a trunk port, it assumes the frame belongs to the native. VLAN yang dipakai untuk frame tanpa tag pada trunk link.
Work back.
You want to configure switch 1 to send VLAN 10 frames. Type over HD you want it. Maybe for modifying the list of VLANs allowed on a strong interface. Want to return it to the default state. Which command will
To
do this?
return it to the default state. Which command will do this? A. Switch port front allowed VLAN default. B. Switch port front allowed VLAN all. C. Switch port front allowed VLAN none.
Yes.
Or D. Switch port front allowed VLAN 1 and 1001 to 1005. Pause the video to think about your answer.
B. Yeah.
The answer is B. Switch port trunk allowed VLAN all. By default, all VLANs are allowed on a trunk port. So switch port trunk allowed VLAN all will return it to the default state. Answer D, by the way, lists the VLANs that exist on a Cisco switch by default. But that's different than the VLANs allowed on the trunk by default. Okay, let's go to question 3. We try to configure an interface on a Cisco switch as a trunk port with the command switch port mode trunk, but the command is rejected. Which command might fix this issue? A. Switch port mode trunk. B. Switch port trunk encapsulation 802.1q. C. Switch port trunk encapsulation .1q. Or D. Switch port trunk encapsulation. The answer is C. Switch port trunk encapsulation .1q. On Cisco switches that support both 802.1q and ISL encapsulations for trunk ports, if you want to manually configure the interface as a trunk, you have to manually specify the encapsulation type with switch port trunk encapsulation .1q. You could use ISL instead, but ISL is almost never used. Okay, let's go to question 4. Which field of the 802.1q tag identifies the VLAN ID of the frame? A. TPID. ID. The answer is B. VID. VID stands for VLAN ID. It is 12 bits long and identifies the VLAN number. TPID stands for Tag Protocol Identifier and uses a hexadecimal value of 8100 to identify the frame as 802.1q tag. TCP stands for Priority Code Point and is used for a class of service, not to tag the VLAN ID. D, VLM, is not a real field of the 802.1q tag. Let's go to the last question, question 5. You configured switch port trunk allowed VLAN add 10 on an interface, but VLAN 10 doesn't appear in the VLANs allowed and active in management domain section of the show interfaces trunk command output. What might be the reason?
Not created
A.
VLAN 10.
VLAN 10 doesn't exist on E. D. VLAN 10 is reserved.
C.
Cannot be used.
VLANs allowed and active in management domain section.
Pause the video to think of
C. The command should be switch port trunk allowed VLAN 10.
The answer is A. VLAN 10 doesn't exist on the switch. If a VLAN doesn't exist on the switch, even if it is allowed on the trunk, it won't appear in the VLANs allowed and active in management domain section of the show interfaces trunk command output. That's all for the quiz. Okay, so as always, there will be supplementary materials for this video. There will be flashcards to use with the software.
VLANs ports are now known as tag ports. Trunk ports are known as untagged ports. Yes. And switches will tag frame sent out of ports with a VLAN number. Trunk port. What is Cisco proprietary VLAN trunking protocol? 802.1q. What is an industry standard VLAN trunking protocol? 1q. Then but one type is inserted after the field of the Ethernet has source or resource pipeline. If you don't want to type it's 32 bits or bytes. What does TPID stand for? It stands for Text Protocol Identifier. What is the scope of bravery and transaction? What does PCP stand for? Control Priority Path. PEI stand Prog eligible and declared. Analysis. TPID field is 16 bits in memory. The TPID field is the weight set to value during the PCP field is in is used for class of Prog eligible such to be resistant. Extra couple identifier. And for the code point. I field is 1 bit. STU stands for Prog eligible field indicates that the program can be graphed if the net has to be drop eligible. The TPID field is PCP field is 2 bits. The field identifies the VLAN the frame belongs to. TPID. The field is used for VLANs served and cannot be used one and 0 and the range of usable VLANs um, 1 to 4 and 9 8 dot 8 dot x and 4 drop eligible integrity. Drop eligible indicator. The two twice the VLAN and PID. Bilans underscore and cannot be 0,009. Sports are known as sports. The 802.1 is issued after the course of test before the pipeline internet. Ports are known as untapped access, which is will take frames sent out of ports with a VLAN number, which is will take frames sent out of ports. TTP addictive is 16 bits. That one will take 4 bytes in length. It is industry standard to trunking. That one key. That's the ID stand for. Bilang ID. That's the ID stand for. Protocol identity. What is this called? Prior VLAN trunk. Built-in network DER. The field is qubits. Priority. Picket point.
Don't call me baby.
Bits. VLAN. VLAN 0 and the default is always set to value of your x. What does the stand for? We will get it. The tree and device will be done on three. Range of usable boundary. Protocol identifier priority course point drop eligible indicator dengan ID. X protocol identifier 15 bits priority course point 3 bits drop eligible identifier eligible indicator drop
Cool.
I will give you more. Sunshine another day. Forever I'll stay with you. On you. Oh, fine. Don't she the one, the one, get you. Along the way, I'll be there to save the day. Superman, I want our day. go. I'm not alone, I'm on the run. All the way, I'll be there. Day, day, Superman. You are yeah. If you're in down, Never been. You have ever my dreams. You with me, you'll be everything I wanted to be. From there, oh no, this will be another weekend for the first time in my imagination. I just I just wanna stay you in my head, everything I wanna be from there to I just wanna say you
That's it. No life. Replace the old life unscarred by trials.
Was the same path. Welcome to Jeremy. This IP lab. This is a free complete course for the CCNA. If you like these videos, please subscribe to follow along with the series. Also, please like and leave a comment, and share the video to help spread this free series of videos. Thanks for your help. Also, remember to download this practice lab from the link in the description and try it out yourself and packet it. If you want more labs like these, I highly recommend picking up Boson NetSim for the CCNA. Click the link in the video description to check it out. It's a network simulator like Packet Tracer, but it's even more powerful, less limited than Packet Tracers, and it includes plenty of pre-made labs with detailed instructions to help you practice and learn. I have collapsed all of the other sections here: network fundamentals, IP connectivity, IP services, and security fundamentals. But the labs that are relevant to what we're studying now are here, in the network access section. Configuring VLANs, VLANs, deleting VLANs. These two are about BGP, which will be covered in day 18's lecture video. VLAN configuration, trunking. Stick around to the end of the video for a preview of a lab that is relevant to what we're studying today. And once again, click the link in the description to see and as we covered in day 17's lecture video. This is the same network topology used in day 17's lecture video. Only the IP addresses have been changed slightly. So let's get started with step 1. Step 1 says to configure the switch interfaces connected to PCs as access ports in the correct VLAN. I'll go on step 1 first. Enter privileged exec mode with enable, then global config mode with configure terminal. So there are two PCs in VLAN 10. Let's configure those first. Interface range F01 to 2. Switch port mode access. Switch port access VLAN 10. And the switch creates VLAN 10 for us. Okay, that's all for these folks. Next up, VLAN 30. Interface range F03 to 4. Switch port mode access. Switch port access VLAN 30. Once again, the switch creates the VLAN for us. Okay, that's all for switch 1 for now. Next, let's go on to switch 2. Enter privileged exec mode with enable, then global config mode with T, configure terminal. I'll configure. Enter privileged exec mode with enable, then global config mode with T, configure terminal. I'll configure VLAN 20 first. Interface X01. Switch port mode access. Switch port access VLAN 20. Next, VLAN 10. Interface range X02 to 3. Switch port mode access. Switch port access VLAN 10. Okay, step 1 is complete. Step 2 is to configure the connection between switch 1 and switch 2 as a trunk, and allow only the necessary VLAN. We should configure an unused VLAN as the native VLAN, and also make sure all necessary VLANs exist on each switch. I'll return to switch 1. Okay, let's configure the interface G01. If you remember from the lecture video, in some switches we have to use the switch port trunk encapsulation.1q command before configuring the interface as a trunk. Let's see if we have to do that here. Switch port trunk, then use the question mark. As you can see, there is no option for encapsulation. This isn't a case of packet tracer not supporting the command, but rather it's because this switch itself only supports .1q encapsulation. As I mentioned in the lecture video, modern switches often don't support Cisco's ISM, since the industry standard .1q is used almost exclusively. So we can go straight to the next command, switch port mode trunk. Now let's allow VLANs 10 and 30. Switch port trunk allowed VLAN 10, 30. Why don't I need to allow VLAN 20 on this? I already explained this in the lecture video, but it's because no hosts in VLAN 20 are connected to this switch. If PC5 in VLAN 20 wants to reach any hosts here, its traffic will be sent to the router first, which will send it back to switch 2 in VLAN 10 or VLAN 30, which will then send it over to switch 1. Watch the lecture video again if you want a more detailed attended are connected to this switch. If PC5 in VLAN 20 wants to reach any hosts here, its traffic will be sent to the router first, which will send it back to switch 2 in VLAN 10 or VLAN 30, which will then send it over to switch 1. Watch the lecture video again if you want a more detailed explanation. Okay, finally, let's set the native VLAN to an unused VLAN. Switch port trunk native VLAN 1001. You can use anything here, just use an unused VLAN. Now, do all of the necessary VLANs exist on this switch? Let's check. Do show VLAN 3. We have VLANs 10 and 30. Looks good. We don't need to create any more VLANs. Okay, now let's go to switch 2. Interface G01. The configurations will be the same as on switch 1. Switch port mode trunk. Switch port trunk allowed VLAN 10, 30. Again, VLAN 20 doesn't need to be allowed. There are no VLAN 20 hosts connected to switch 1, so switch 2 doesn't need to send VLAN 20 traffic along this trunk. Okay, next set the native VLAN. Switch port trunk native VLAN 1001. Okay, that's all for the configuration of the trunk. Now, do all necessary VLANs exist on the switch? Do show VLAN 3. We have VLANs 10 and 20. Let's do another show command. Do show interfaces trunk. So VLANs 10 and 30 are allowed on the trunk, which is good. However, look under here. VLANs allowed and active in management domain displays only VLAN 10. That's a problem. It means switch 2 won't actually receive VLAN 30 traffic on this trunk. That's because VLAN 30 doesn't exist yet on the switch. VLANs 10 and 20 were automatically created when we configured access ports in those VLANs, but VLAN 30 wasn't created. So let's make it. VLAN 30. Fix it. Do show interfaces trunk. Okay, now you can see that it appears here. That's all for step 2. Step 3 is to configure the connection between switch 2 and R1 using a router on a stick. Let's quickly do the configuration here on switch 2 first. It will be mostly the same as the G01 trunk, except we must allow all 3 VLANs. Interface G02. Switch port mode trunk. Switch port trunk allowed VLAN 10, 20, 30. Switch port trunk native VLAN 1001. That's all for the switch. Now let's go on to R1. Enter privileged exec mode with enable, then prompt T to enter global config mode. First, let's enable the physical interface. Interface G00, no shutdown. As I have said many times before, Cisco router interfaces are disabled by default. Now let's configure the VLAN 10 subinterface. Interface G00.10. This subinterface number doesn't have to match the VLAN number, but you really should make it match. Okay, let's set the VLAN number itself. Encapsulation .1Q 10. Finally, the IP address. It should be the last usable address of the subnet, according to the instructions. IP address 10.0.0.62 255.255.255.192. Okay, that's it. I get the question sometimes. Why does the router address have to be the last usable address? Well, it doesn't have to be, but you should have a system you use. Either the first usable address or the last usable address as the gateway address for the subnet. So there is consistency across the network. Don't just use a random address for the router, or it will be difficult to understand things in a large network. Okay, now let's configure VLAN 20's subinterface. Interface G00.20. Encapsulation .1Q20. Once again, set the last usable address as the router's address. IP address 10.0.0.136 255.255.255.192. Okay, finally is VLAN 30 subinterface. Interface G00.30. Encapsulation .1Q30. IP address 10.0.0.190 255.255.255.192, which is the last usable address of the VLAN 30 subnet. So that's all of the configurations for this lab. Next up is the test connectivity. If everything is configured correctly, each PC should be able to ping any other PC. I'll do some pings from PC 7 to test. Let's ping another PC in VLAN 10. Okay, no problems here. Yeah.
Okay, now we have to configure for the day 70 lab for the VLANs part 2 that includes all the trunk ports. For the last lab, we do all the access port. So now we have to configure the trunk ports on a single cable. For the last lab, we do access VLAN for the 3 cables that connects to the router to the switch, and for the trunk ports we connect to the 2 switches and only require the trunk ports to carry all the multiple VLANs in one interface. So for the first step, it says configure the switch interfaces connected to PCs as access port in the correct VLAN. So we open switch 1. So we open switch 1 here and go to CLI, enable config interface F02 to F01 interface name F01 export mode test which port access VLAN 10. Okay. Test VLAN 10 and it interface rank F 2 3 4 port not access, port access 930. We can figure all the IP address on each pieces. So for the PC1, we see default gateway is 2. We configure on this. We move to the switch room. Our press F0. Switch port not access. Switch port access. VLAN 20. Exit. Surface frame F0223. Switch port not access. Switch port access. VLAN 10. Closing when you are right. Now we have already configured the connections to all the PCs in their network. For the VLAN, so we have to check show show VLAN rate. As you can see, I forgot to change the name to VLAN 10 and already configure the correct VLAN orders for each interface. VLAN 10. We show VLAN rate. F01 and then this. Okay, now we have to configure the connection between switch 1 and switch 2 as a trunk, allowing all the necessary VLANs, configure VLAN and VLAN. Actually, all necessary VLAN exist on each switch. We have to configure the trunk ports. Okay, configure and select the correct interface. Ports interface G01 yes. Which port and
That's it. So with access to the plan, you do as from switch 1. Let's see, let's make it top. And also make switch port access VLAN 10. Okay. Step 1, the connection. Which you configure switch for 1. You can access. Let's see if we have to do that here. Switch port front then use the question mark. As you can see, there is no option to command, so it print is used. Why don't I need to allow
switch port ground port run switch port run out VLAN melewatkan allowed VLAN 10 switch port run dari VLAN 2001 to show VLAN brief to show surface VLAN show strong interface D10 switch port mode 1 switch port terang allowed VLAN 1 and jadi switch port terang and VLAN 1 exit to show interface out and to
now let's align this. You have to once click back, on using the switch. Okay, now let's go to switch 2. These will be again which one? VLAN 1000. Let's do another. We have VLANs 10 and 20. Let's do another show command. This on the switch. Do show VLAN brief. We have VLANs 10 and 20 front. We receive VLAN on the switch. After it goes, all connection be good. Interface G trunk allowed VLAN 10, 20, 30. Switch.
figure to G02 interface G02 switch port mode run switch port run allowed VLAN 10 signing switch port run and VLAN 1 exit interface figure on other enable conf interface 0 and set that press the 0.10 the address and standard 0. Okay. This patient what is then the M.
For price exact zero slogans, but you really should pick the ad 5 that yes, so okay, 0 plus. Once again,
Zero interface G00 and caps 1 Q and S and Q 126 126 S P S
game 1.19 updatable ad live, line 37. Each PC should be able to contain any other PC. How do campaigns from PCs? It's
it should be connected to each. We can't do this no more. Baby, here go again, making me love you. Let it all go. Like a tattoo. Game and the with one more night. And oh, I say it a million times. And I'll always stay with you one more night. Gotta tell you, it's telling you yes. So out of hand. I'm hurting myself. Innocent silence is here. Making me laugh. Which you want to PC Battlefield 20? So it will be through the switch one. Goes to the switch one. Because this interface carries VLAN 10 and VLAN 30. It will be true on switch 1, but the switch 1, switch 2 also not contains VLAN 20 because switch 1 interface is connected with VLAN 20. It will be true. Okay. Go to R1. Again, because you already know the IP address for the VLAN 20 and goes to the VLAN 20. For the route for TP2, I think it's gonna be it goes to R1 again. I want to ping VLAN 30. So ping and 0, 0, and 30. Masih ping gonna be from switch 1 and it goes to switch 1 to also.
Jauh kan dia ditanya. Iya. Apa bawa apa? Di bawah apa lagi? Apa ini?
Because the VLAN is not under one network, it will be carries through the trunk ports on switch 1 to switch 2, and then when the switch 2 it will be forwarded to R1s that has that VLAN tag, the VLAN 30 tag, and then it will be switching the right route for the VLAN 30 and forward to switch 2, switch 1.
5 orang.
And 10.0.0.1.
Nggak ada coachnya.
Okay, no problems here. But
Main pin.
in simulation.
Main
Okay,
nggak?
send that king again.
Lagi.
And 10.0.0.1. As you can see, because PC1 is in the same VLAN, the same subnet, PC7 sends the frame directly to PC1. No need for inter-VLAN routing. Now let's go back to real time and try to ping PC5 on VLAN 20. Ping 10.0.0.65.
Kalau yang bapak kedua aman. Yang nggak tahu kemanain. Kalau bapak ketiga kapan?
Okay, the ping works. Let's take a look in simulation mode. In 10.0.0.65. Notice that the ping has to travel to R1
Balik
first
mana?
before being sent back to switch 2 and then to PC5, and the reply follows the same path.
Dari korek di bawah
Okay, back to real-time mode. And finally, we will ping PC3 in VLSM 20. In 10.0.0.129.
Bisa lah itu ngetik 3000.
Okay, the ping
Mau.
works. And once again, let's take a look at it in
Mana
simulation
bisa?
mode.
Lagi.
In 10.0.0.129. Once again, the ping must go to R1 first to be routed, then goes to switch 2 and switch 1 before reaching PC3, and then it follows the same path back. 10.0.0.129. Once again, the ping must go to R1 first to be routed, then goes to switch 2 and switch 1
Dapat ini dapat.
before reaching PC3, and then it follows the same path back.
Males kontol.
Gantian pin. Ah,
Kalau ketemu gitu ya. Iya. Kayak nggak punya pasif bang. Kurang dia. Yang ngaji daripada Sun pasti. Skill 1 doang cok. 1 doang meledak anjing.
Okay, that's all for this lab.
Jangan gua.
Okay, let's move on to the boson
Masih
testing
aman.
preview.
Kalau haji,
I've selected
kalau
one
Sun
lab
ini
here. Feature
kebirinya
VLAN routing 1.
risom dia.
Click on the lab and get a little preview. And then click on load lab.
Sampai lubang kuping dipakai.
And then here's the lab. There's the objective here, the lab topology. This is very much like the quick. The default VLAN, switchport mode, switchport trunk encapsulation. Okay, next up, step 5. There is no documentation present about your network. You must learn which ports PC1 and PC2 are connected to on switch 1 before adding each PC the appropriate.
Asal dia nolan, enak nih nolan.
On some newer devices, you'll probably find
Nolan oke sih nolan. Yin kalau Yin beda anjing. Diangkat chamber. Oh, tembel ada kari loh padahal. Itu gede ya. Kari got masalahnya. Jalan dia.
ya listening. Ah, bangsat.
Sumpah kari got elis. Alet enggak. Apa? Just anjing. Ngecerit cok, ngecerit.